Events. Events are code that waits for a specific thing to happen to trigger them. A better way to phrase that may be code that waits until an event fires, which runs the code. Examples of built-in events to Unity are onMouseUp or onCollision. In this example, I've created an event manager to handle the events we will be testing. This event manager also uses a queue system to allow for event queuing to ensure that events fire in the order that they are triggered. I'll start from the top. For the event queue, we wanted to represent our events with a struct called myEvent. It is given an ID string to access it by, and can be given other data to be used in the future. It's given an arbitrary otherInfo integer to demonstrate this. Now in the event manager class. This class contains a delegate called callback method that will be used to contain each event's function or functions. It contains a queue for events to be added to. It contains a dictionary of strings to callback methods, allowing us to access events by their names. Then it has 5 functions: subscribe listener, unsubscribe listener, trigger event, queue event, and next event. To put what each of these do very quickly, subscribe listener takes an event name and a delegate and adds them to the dictionary of listeners. Unsubscribe listener removes a delegate from a certain event or removes the listener entirely. Trigger event actually runs the function tied to the event. Queue event adds a new event to the queue, and next event triggers the first event in the queue, then removes it from the queue. When used like so, you can bind a function or multiple to a custom event that runs when a specific thing happens. Object pooling. Object pooling is a method of saving on processing by creating an existing pool of objects to pull from, rather than instantiating a new object every time one is needed. In this example, I've created an object pool manager, which will control and manage the object pool. Inside it, we keep a list of game objects called pool, which we will later pull our objects from. In the initPool function, we instantiate the object we will be pooling a certain number of times, then deactivate and add all of those objects to the pool. Now whenever I need to spawn one of these objects, I can call the getObject function. This function's parameters are set up to be exactly like the instantiate function, having an object, a position, and a rotation. In the function, I first loop through the pool to find the first available inactive object. Once found, I set the variables to the one's input and then activate it. In the case that none are available, getObject will just create a new one and add it to the pool, expanding the pool's size. Link. Link stands for Language Integrated Query. It's essentially a query system similar to SQL, which allows us to make use of queries on larger datasets to get specific information. For example, in our object pooling demo, we created a lot of cubes. If I wanted to quickly search through the pool of cubes and find the ones that have been used, I would do this. This syntax just means that we'll check the pool for objects whose number of times spawned is over 1 and select them. Once selected, we convert it to a list called old objects. This is called filtering. We can later loop through the list of old objects and turn them red. Link also has the ability to very quickly sort data. For example, if I wanted a list of the cubes ordered by the amount of times they have been spawned, I would do this. Simply by adding the line order by number of times spawned, it sorts the selections. I use this to create a sorted list, then set the most spawned cube to a gold color. Link also has various other functionality, but one I think is cool is accept. Accept is a function which can be used on a list to basically say, I want this list except for the items in this other list. For example, here I used it to find the new objects by taking the list of all objects in the pool and accepting old objects, aka already used objects. I later looped through the new objects list to turn them blue. As a final note to break character for a moment, I didn't know exactly what to do for inversion of control in this project, so I didn't mention it. I know at its core it just means to inherit functionality from interfaces upwards rather than inheriting functionality via child objects downward with regular object-oriented programming.